So question number 4 gives us this function right here, and we basically need to find the intervals where f is increasing and decreasing. So basically, to find, first thing, we need to find our critical values. So our critical values, to find them, we're gonna need to do f of x equals 2x to the third minus 3x squared minus 36. Here we're gonna get the derivative. We're gonna do the derivative. That will be square minus x squared. Put the common factor here. You're gonna have 6x, x minus 1. So our x, and then to find the critical values, the derivative needs to be equal to 0. So if we analyze, we can agree that the values of x could be 0, like here, or could be 1. So basically, doing our line here, if we mark a line, I'm gonna have our values here, and we know that, like, here's minus 1, there's a critical value, here 0, here 1, here we can have 2, just in case. And basically, if we substitute, if we analyze the values, substitute minus 1 here, we have the derivative of the function is bigger than 0. So the function here is increasing, all right? And if we substitute, like here, like 1/2, for example, to find in this interval right here, we can see that the derivative of the function is less than 0. So the function is decreasing right here. However, after 1, here, when function is equal to 2, we can see the derivative is bigger than 0 and f is increasing. So look into this graph, we can agree, we can realize, we can notice that it is increasing from infinity to 0. And then here at 0, we notice that it starts to decrease. So but here it also, after 1, it's increasing too. So we need to add union with 1 infinity. It's increasing. However, it is decreasing in the points 0 and between 0 and 1. So here is decreasing. Okay, so this is our letter A for the question number. So letter B is asking us to find the local minimum and local maximum values of the function. Basically, to find the, we saw here interpreting the graph that in f of 0, we have the function increasing and then it starts to decrease. So we're gonna have an absolute maximum in 0. So if we do function f of 0, we're gonna plug here. I'm gonna have 0, 0, minus 36. So minus 36 here. And in 1, we can see that it decreased, but in 1, it starts to increase again. So basically, 1 will be our minimum value. If we substitute here, we're gonna have 1, 2, 2. So 2 minus 3 minus 1 minus 36 equals minus 37. Here, so here we're gonna have minus 37. And this will be, of course, our local maximum and minimum. Here in letter C, it's asking us to find the inflection points and the intervals where f is concave up and concave down. So basically, first thing, we're gonna need to find the second derivative. Second derivative of this function right here. We're gonna do the derivative of this. We're gonna have 12x minus 6. That will be the derivative of that function right there. And we're gonna do it equals 0. If we do it equals 0, we're gonna have simply 1/2 our x will be equals to 1/2 because we're gonna pass 6 there, positive, then 6 over 12, 1/2. Okay, and so here basically our point of inflection, they gonna be this 1/2 that we found, and the function relative to this 1/2. If we substitute here, we're gonna do 1/2 over 3 minus 3 x 1/2 over 2 minus 36. And doing this in the calculator, I'm gonna have, gonna have here 2 over 3. Gonna be doing this in the calculator. We're gonna find that f of 1 over 2 will be 56.5 minus 56.5. So this will be our point of inflection here. And point of inflection basically is the point where it changes the concavity. And also in the interpreting here, we're gonna see that the point of inflection will be in 1/2. So we can all agree that here it's going up, so the concavity will be like this. So will be from minus infinity to 0, because here in 0 it starts to decrease, and in 1/2 it changes, is the inflection point, and then the concavity will be, so concavity down, and the concavity up will be from 1 to infinity up. So basically here it's asking us to strat the graph. I already did a draft right here, and basically to strat this graph, we're gonna look in the information that we found. So basically we know that concavity right here is concavity down until it's 0, so we can do something like this. And then here, when it goes to 2 to 1/2, we can see that there's an inflection point that changes, and then here the concavity from 1 to infinity is concavity up. Okay, so our graph will be something like this. Of course, using the values, we also could see that is decreasing between 0 and 1. So here is going to decrease between 0 and 1, but here is increasing, and here it's increasing. It's increasing from 1 to infinity and from minus infinity to 0. However, the concavities are different. So here we need to do the concavity down, here concavity up.